We're going to go through examples 4 and 5 from notes 2.6, which covers combinations of functions. These examples actually cover composition of functions. And in addition to the operations that we talked about last class, which were addition, subtraction, multiplication, and division, there is another way to combine two functions. And this way is called composition. Composition is similar to evaluate functions for a given value, except in composition, we substitute an entire function into another function. That's what I have up here. And we've already done this, I just never named it as composition. The notation, let's go over that first. The notation is here in the notes, and it's F open circle G. We would say that F composed with G. And there are two notations, the open circle one and then the one that's more intuitive. So typically if I see F open circle of G of X, I will rewrite that in the more intuitive way, which is F of G of X. And that means put the G of X function into the F function. What we're doing in composition is, let's say we have a function named F, and normally we just put some value. We put X in, but now we're going to put a whole function in, G of X in. What's going to come out of that function is going to be F of G of X. That's the idea of composition. So let's do a couple of examples. In example 4, I've defined two functions, F of X, which is 5x minus 4, and G of X, which is x squared plus 3. So in the first example, we have F composed with G of X. I would start by rewriting this as F of G of X using the more intuitive notation. And what this means is we are going to put the G of X function into the F function. So everywhere we see X in F of X, we're going to put the expression x squared plus 3. So the next step, I would write this as F of, instead of G of X, I would put in x squared plus 3. And now everywhere I see x in F of X, so here I'm going to substitute x squared plus 3. So this is going to become 5 times x squared plus 3 minus 4. And now we're going to distribute and simplify. So this is 5x squared plus 15 minus 4, which is 5x squared plus 11. And that is F composed with G of X. Next, we're going to compose the other way. So we have G composed with F of X. Let's rewrite that as G of F of X. And that's going to be, I'll try to keep my colors straight here. G will do red, and F of X, we're going to substitute in 5x minus 4. So everywhere we see x in G of X, right here, we're going to put the expression 5x minus 4. So this is going to become 5x minus 4 squared, because we have x squared up there, plus 3, which is the rest of the G of X function. And now we're going to square 5x minus 4, so that's going to be 25x squared minus 20x minus 20x. I'm going to combine that to be minus 40x plus 16 plus 3. Combining like terms, we'll get 25x squared minus 40x plus 19. So that is G of F of X. And in example C here, we can actually compose a function with itself. And here I've used the more intuitive notation. So G of X, so that means we're going to do G of x squared plus 3. So everywhere we see x in G of X, we're going to substitute in x squared plus 3. So this is going to become x squared plus 3 squared. And then we still need to add 3. X squared plus 3 squared is going to become x to the 4th plus 3x squared plus 3x squared, which will be 6x squared plus 9. And we still have to put the plus 3 there. And then we'll get x to the 4th plus 6x squared plus 12 is going to be G of X. 4D, just as we can evaluate functions at a given value, we can also evaluate the composition of functions, because the composition of a function, of two functions, is another function. So I want to show you two ways for this particular example to find f composed with g of 2. The first way is we've already found f of g of x, so we can use example 4a. In this situation, we know that f of g of x, we already found that, is 5x squared plus 11. So if we want to know f of g of 2, this is the same thing as f of g of 2, we can put 2 in for x here. So that's going to be 5 times 2 squared plus 11. So that's 5 times 4, which is 20, plus 11, which is 31. The second way is we're going to evaluate f composed of g of 2, which is f of g of 2. And here, when you're evaluating compositions of functions, start at the inside and work out. So let's find out what g of 2 is. G of 2, going back to the g of x function, which was x squared plus 3, is going to be 2 squared plus 3, which is 7. And now we know what g of 2 is, so we're really finding f of 7, because g of 2 is 7. F of 7, going back to the f function, is 5 times 7 minus 4, which is 35 minus 4, which is 31. In example 5, we are not given an expression for the functions. We're not given an equation, but we can still evaluate combinations of functions numerically. Here we're given a table. So the way this table works is we're given x is the top row, and then we're given specific values for f and g of x. So in the first one, we're trying to find f plus g of 2. So this is addition. So that means we need to find f of 2 plus g of 2. F of 2, I'm going to go over here to where x equals 2. F of 2 is the value right here, which is 3. G of 2, going further down in the column, G of 2 is this value right here, which is 1. And 3 plus 1 is 4. So f plus g of 2 is going to be 3 plus 1, which is 4. Let's do the next example. We're going to do f composed with g of 2. So I'm going to rewrite that as f of g of 2. We're going to start at the inside and work out. So the first thing we need to find is g of 2. Looking in this column, g of 2 is 1. So this is the same thing as f of 1. And f of 1, going up one row in this column, f of 1 is right here. Oh, no, sorry, wrong place. F of 1, let's go over here. This is where x is 1. F of 1 is 2. Let's do the last example. I'll erase what I put on here. We're asked to find g of f of 2. So I've got g of f of 2. Start at the inside and work out. So the first thing we need to find out is what is f of 2. F of 2, we've already done that one. F of 2, go here. This is where x is 2. F of 2 is this value right here. So this is going to be g of 3. And g of 3, let's go to the column where x is 3. Go to the g row. And g of 3 is equal to 2.